In this lesson, we are going to talk about more logic, which you're going to notice there are a lot more words in this section than there are numbers. So there's going to be a lot more writing. So first off, we have conditional statements, and that's how most of our sentences are going to start. And it's a statement that can be written in if-then form. And I'll show you what that means and how we can change that. For symbols, for the symbolic form of how we're going to write that, is going to be P, and then your arrow to the right, and then Q. Remember when we were filling out those cards that the arrow means implies. So P implies Q, or we can read it as if then. It's right over here, if then, or if P, then Q. There will be a first half of your sentence and the second half of the sentence. The first half of your sentence is going to go with the if, and that is going to be the hypothesis. And it goes with the if part of your sentence. And the conclusion will be mostly at the end, and it will go with the then part of your sentence. So for an example, if you look at number 1, if you live in Nashville, then you live in Tennessee. So we need to write what the hypothesis is and the conclusion. So you want to look for those if-then words. So if you see right here, we've got the if, so that means that this right after it is going to be our hypothesis. When we see the then, the part right after it will be our conclusions. Now we just have to write out that sentence. So the hypothesis is you live in Nashville. The conclusion, we're going to write you live in Tennessee. So do not put the words if and then with your hypothesis and conclusion. While we're writing these, you also want to think of if it's true or false. So if we live in Nashville, then we live in Tennessee. That's always going to be the case because Nashville is in the state of Tennessee. For number 2, if the sum of the measures of two angles is 90 degrees, then they are complementary angles. So remember, you're looking for the if part, and right after it is going to be our hypothesis. So we write the sum of the measures of two angles is 90 degrees. Next, we are going to be writing the conclusions. You want to look for the then of your sentence, and after it, they are complementary angles is our conclusion. And if you're wondering what this little symbol is right here, that just means angle. So I'm just writing the symbol for the angle instead of the word. Now for number 3, I would like you to do the hypothesis on your own on the far right side of your screen. All right, so what you should have put, since your if is right here, you should have written a quadrilateral is a square. Now for the conclusion, I want you to do your conclusion also on your own, so on the far right side of your screen. What you should have put for your conclusion, since the then is right here, is it has 4 right angles. So what we're going to do next down here is we are going to write conditional statements. So we're going to write the following statements into if-then form. So that if you notice, there's no if and then written in here. So we have to figure out what is the hypothesis, what is the conclusion, so what happens first, what happens second, and we need to write out our if-then sentence. So with this first one, an obtuse angle has a measure greater than 90 degrees. So this means that if we have an obtuse angle, then we know that the measure is going to be greater than 90 degrees. So when we write it out, we're going to write if an angle is obtuse, then it has a measure greater than 90 degrees. So notice we have the then right here, so the conclusions at the end, and we have the if right here. So we're going to do the same thing for number 5. So all numbers divisible by 4 are also divisible by 2. So what the sentence should look like is if a number is divisible by 4, then it is also divisible by 2. Okay, so on number 6 now, I want you to work this one out on your own. So states on the East Coast border the Atlantic Ocean. So I want you to, on the side, I want you to list out what is your if-then statement going to be. So what your answer should look like is if a state is on the East Coast, then it borders the Atlantic Ocean. So for number 7, Valentine's Day is in February. So if it is Valentine's Day, then we know it is in February. Or if it is Valentine's Day, then it is February, since if we were on that actual date. So for number 8, prime numbers only have two factors, 1 and itself. So for the first part, we could say if it is a prime number, or if a number is prime, then its only two factors are 1 and itself. So on the second page of your notes, we're going to talk about these 3 different types of related conditionals. So it will still be written in if-then form, except we are going to be adjusting that original conditional statement slightly. So inverse is formed by negating the hypothesis and conclusion. So what that means is really you're doing the opposite of what was written. So it stays in the same order, but it's opposite. So for example, our Valentine's question that we had before, if it is Valentine's Day, then it is February. We could say if it is not Valentine's Day, then it is not February. So we're saying the opposite of both parts, the hypothesis and the conclusion. So for the symbols, what we're going to use for that is instead of our P implies Q, we're going to say not P implies not Q. So we're putting a little squiggly in front of it. That means that we're negating what the hypothesis is and negating what the conclusion is. Next is converse. In converse, we are exchanging the hypothesis and conclusion in our sentence. So for the order is going to be switching. So the order in my sentence is going to switch. So this means that my Q will really come first, my conclusion will come first, and then it will be my hypothesis. For the contrapositive, it's really a combination of both of those. So for our definition, we have it's formed by negating and exchanging the hypothesis and conclusion. So we're going to do both. So we're going to have the opposite of Q implies the opposite of P. So we're switching the order and putting the opposite sign. And not really the opposite sign, but the opposite meaning of that part of your sentence. So for the example 1 down below, if it is Saturday, then there is no school. So what we are going to do is we're going to write the inverse, converse, and contrapositive, and then we're also going to say if that statement is true or false. Because if it is false, just like we did before, we need to write a counter example. So for inverse, this is where we keep the order the same, but we're putting the nots in there. So this would be, if it is not Saturday, then there is school. So if you notice that for the first part we included the not, we inserted the not in there. For the second half, the conclusion, there was already a not basically in our sentence, so we need to take it away, so it's now missing. So if it is not Saturday, then there is school. Is that always going to be true? No, because if it's not Saturday, it could be Monday, Tuesday, Wednesday, Thursday, or Friday, or Sunday, and on Sunday, there is not school. So that's what we would write for our counter example. All right, for the converse, we are switching the order of it. So the hypothesis is now last, the conclusion is now first. So since the conclusion is there is no school, that's what we're starting with. So if there is no school, then we need to put our hypothesis. So then it is Saturday. So again, we want to think of a counterexample if this is false. If there is no school, so think of that could be any day of the week. So if there is no school, then it is going to be Saturday. Well, that's not always the case because of Sunday again. If there's no school on that day, it could be Sunday as well. So remember when you're writing a counterexample, it's like you're being the devil's advocate. So you're saying, well, in this situation, that's not always going to be true. All right, for our counterexample, we are switching and putting the knots. So it's opposite order, and we're putting the knots in there, so the opposite part of our sentence. So switching the order is if there is no school, then it is Saturday, but now we need to put the knots in there as well, or take it away. So if there is school, then the original conclusion would be it is Saturday, but now we need to say the opposite of that, so it is not Saturday. And if there is school, then it is not Saturday. That is a true statement. So we don't have to come up with a counter example for that one. All right, so for this number 2, we can see the if part is right here, so that means that this is our hypothesis, so that's my P. We have the then, so both numbers must be odd is my conclusion. So when we write our inverse, remember the inverse is negating them, so the opposite of P implies the opposite of Q, so we need to put the opposite parts in there. So if the product of two numbers is not odd, which means it would be even, so we could just say is even, then both numbers must be even, since again, even would mean that it's not odd. All right, so we need to figure out the truth value and see if this is a true statement or not. So are there any numbers that it comes out as an even number when you multiply them, but both of them are not even? So let's see, 2 times 2 gives us a 4. What about 2 times 3 gives us a 6? So this would be false, because 2 times 3 gives us 6, and that would be my example. So you can see that the product of two numbers, so 2 times 3, is even. Then both numbers must be even is what they're always saying, but 3 is not an even number. All right, for my converse, remember the converse is we need to switch the order. So I'm going to put my conclusion first, then the hypothesis. So off to the side, I want you to write out what that sentence would look like for your converse. All right, so now that you've written what your converse is, this is what it should look like. If two numbers are odd, then their product is odd. And if you notice, when we switch the order, you think what the subject is of your sentence. So you're talking about two numbers, so you do need to mention that part of it at the very beginning of your sentence. Otherwise, it's not really set up correctly. So next, for your truth value, now off to the side again, I want you to fill in what is your truth value of that statement. So is that a true statement or false? And if it's false, I want you to give me a counter example of it. All right, so you should have put that that is a true statement. So if two numbers are odd, then their product is always going to be odd. And if you're not sure, double check. So 3 times 3 gives you 9. We have 1 times 3 gives us a 3. We have 5 times 7 gives us 35. And you can kind of notice the pattern that that's always going to be true. All right, for the contrapositive, remember we are negating them, but also doing them in a different order. So it's the not of the conclusion, and then the not of the hypothesis. So what our sentence would be is if two numbers are even, and remember when that is written, that just means that it's not odd. So if two numbers are even, then their product is even. All right, so to figure out if that's true or false, we have to come up with some examples and think of it. So if two numbers are even, so let's say 2 and 4, then their product is even. So we're saying that that's always going to be the case. So 2 times 4 gives me 8, that works. Let's see, 6 times 4 gives me 24, that also works. And if we continue, it's always going to be even as well. So that one is also true. All right, so for this very last question, if the temperature is 25 degrees Fahrenheit, then it is below freezing. So for the inverse, I would like you to write the inverse statement because you haven't done that one yet. So remember, this is the one where you keep it the same order, but you're putting the nots in there. And afterwards, I also want you to tell me if it's what the truth value is. And if it is true, you just have to put true. If it is false, then you're going to put a counter example. So go ahead and put that off to the side right now. All right, so for the inverse, you should have written, if the temperature is not 25 degrees Fahrenheit, then it is not below freezing. For your truth value, you should have put false, because if it's not 25 degrees Fahrenheit, it could be 26, could be 27, 28, 29, 30, it could be 75, but there's a few numbers, so 26, 27, 28, 29, 30, 31, that would be below freezing. So any of those would be your counterexample. So it could be 28 degrees, and that is still below freezing. Also, you could have had a temperature that was negative or less than the 25, and any of those would also work. For the converse, remember we are going to switch the order. So the conclusion needs to go first. So if it is below freezing, then the temperature is 25 degrees. So for the truth value, that would also be false, because if it's below freezing, it could be any different numbers, so 31, 30, 29, and on, but they're saying that the temperature is exactly 25 degrees. So it could be any of those other degrees. So maybe it could be 20 degrees. It's still below freezing, but it's not 25 degrees. For the very last one, contrapositive, we need to switch the order and put the nots in there. So the negation of Q and then your negation of P. So the opposite of your conclusion. So if it is not below freezing, then the temperature is not 25 degrees. So for our truth value, if it is not below freezing, so that means it would be anything above freezing, so 33, 34, 35, and on up, then the temperature is not 25 degrees. And that's true because it will never be 25 degrees if it is above freezing. So that is a true statement. So remember, you want to know how to write a conditional statement, how to take the if-then statement and label your hypothesis and conclusion. You also want to be able to write the if-then statement and identify the inverse, converse, and contrapositive, and being able to write the truth value along with each of those.